Hello, I'm Eric Snodgrass, and thank you for watching today's midday weather outlook for the southern region brought to you by Nutrien Ag Solutions. Well, throughout the week as we were watching this jet stream pattern emerge, I thought it'd be kind of fun to take a moment in this video to teach you some cool stuff about the flow of the atmosphere. What we're looking at here is the winds deep in the atmosphere. This is like 6 miles above our heads. And this feature you see right here, these fast winds in that area, that is part of what's called the polar jet stream. It's got a few important features. There's a deep trough still sitting off the west coast of the United States. There's a trough that's sweeping through the Midwest in this area, and there's a cutoff low sitting right in through here. But for the southern region, I want you to focus on this. What I just circled is part of what's called the subtropical jet stream, and it's moving off in a direction like that. To the south of it is a ridge right here. You can see it spinning clockwise. Now, why take the time to explain this to you? You often hear meteorologists talk about how weather systems have energy in the upper levels. I don't like to use that. That's too generic and doesn't make any sense. Let me tell you the real terms that we're actually taught. We search for regions of upper level support by looking for areas of upper level diverging winds. And how we look for that is we look for when the speed of the wind changes aloft. And it's all driven by temperature differences, by the way. So what a simple rule that we're taught looks like when we look at a jet streak like this, again, and a jet streak is this little pocket, I'll show it to you in black now, of faster moving winds like you see right in through here, is we're trained to divide them up into 4 quadrants. Okay, one has an east-west running quadrant, the other has a north-south. All right, so when we divide them up like this, remember this little trick. There's divergence as you enter the jet streak and go to the right, so I'll put a little R down here, and then as you exit the jet streak and go to the left, which is up here. Now, if I get rid of those R's and L's, what I want you to notice is that I wrote D's where we have good upper level support for the development of low pressure. Now, how does that work? Well, if I have divergence aloft, the air is spreading apart aloft, I must fill it in from the bottom. And if I fill it in from the bottom, the air comes into that low and rises. It has to go up because it just can't sit there. So as it rises, it can take the moisture, in this case, which is coming from the Gulf of Mexico, and that moist air is forced to rise where it cools in the upper levels of the atmosphere, produces clouds and condensation, through condensation, and then eventually precipitation. So we're always looking for areas of upper level divergence. And this is how you get it from a jet streak. You can also get it as you come out of a bend to the south like this. Okay, this is called our curvature effect. And right in through here, you get divergence happening. So what's the point of me telling you all this? Well, at the surface right now, this is what's emerging. Throughout the day today, low pressure will be developing here and here. We already have a low sitting here, and then stacked up in the North Pacific, we've got 2 massive lows, but thankfully those are going to be an issue for you later in the forecast video. But these lows that you see here, this one right down here that will be developing, look at the moisture that it is pulling out of the Gulf of Mexico. That'll go right along this leading front and produce a lot more precipitation today. So we've got kind of 3 of these things stacked up here in the eastern half of North America, and the results of which means we're going to be adding more precipitation over this particular area, adding to what we've just seen over the last 48 hours. We've had some locally very heavy rainfall, and we do have flood watches out through this quarter because later on today, as a new low pressure system develops in eastern Texas and Oklahoma, it will be dragging more precipitation through. So starting you off, this was the rainfall early this morning. Let's pause it right about here. We see that throughout the day today, more rainfall is expected on that boundary, stretching from Arkansas through the middle part of Tennessee, Mississippi, getting here into Alabama and Georgia. Now, some places in here have not seen rainfall in a long time, and this rain is falling on very hard ground. So there will be a flash flood worry today just because the rain won't be able to soak in quite as fast as we want. Now, while this is happening, you're going to see a low. Well, you can't see because I don't have pressure contoured, but a low is actually redeveloping right into this area later on today, this afternoon, this evening. And it's linked up with this low sitting here. And that low's front goes right into this low, and the 2 things are going to push together through the next 48 hours or so across the eastern half of our southern region. And this boundary here will eventually come through parts of the Mid-South, so Tennessee and Kentucky, bringing in more precipitation. Now behind this, so you see that system clears out there. Behind this, high pressure builds in and everything kind of clears out by the time we get to midday on Wednesday. But that is why we're expecting more heavy rain throughout the mid-morning and mid-afternoon hours across our southern region. But we see it clearing out as it moves over toward the Carolinas by early Wednesday, getting through middle of the day on Wednesday. So that is the reason Well, these two systems exist, and I hope you found that informative because we watch the jet stream continually. Now, after that passes through, we're going to get through much of the rest of this week relatively dry. But we are watching a feature right down here coming out of the Bay of Campeche. So switching now over to tropical dynamics, we need to be seeing how that particular system is going to be moving through. But before I do that, let's at least see what we're anticipating in terms of rainfall through Thursday, okay, at least through mid-morning on Thursday. We can see that with that trailing front sweeping through and the frontal boundaries already positioned right in through here, we might be bringing in an additional 1 to 3 inches of rainfall in and around this particular corridor. So keep a very close eye out today on the radar and tomorrow on the radar to see how much rain we are going to get through this area, because remember that soil in some of those locations is pan hard, and as a result it won't soak in as fast as we want. Well, the tropical dynamic discussion is due to a big cluster of thunderstorms that's sitting here kind of over Central America but near the Yucatan Peninsula. It will be moving into the Bay of Campeche, and why I'm concerned about this is not over the development of another big tropical system, because we can see that many of our modeling centers, look at the tucked away figure in the upper right, have really given this a low probability of even becoming a tropical depression. It doesn't have to become a tropical system in order to be powerful. This is going to be producing a lot of moisture into the mid and upper levels of the atmosphere that can advect or move as the jet stream pulls it along into our southern region again. So if we saw round 1 was what was coming in the next couple of days, this is the beginning of round 2/3. Now let me show you what I mean. When we pull this out over the next 10 days, now this is just an operational model run here, okay, so we're just looking at one run. What we see here is total accumulated precipitation through the next 10 days. We have our boundaries sitting right in through here. That's our big precipitation maker in the near term. But can you see the heavier rainfall amounts that were coming right in through this area? Now why I show you the GFS model is to let you know that this particular run may be the driest I've seen for this area, because comparing it to the European or other runs, this moisture has been getting drawn a bit further to the north here and hitting some of the same regions that have been quite wet. Let me show you the timing on it, and we'll talk about some of the model differences. So this again we've seen through here, so this gets us to 1 a.m. on Thursday. Let's now see the end of our week, relatively dry Thursday into Friday, but you see this big pulse of moisture coming up here into the Gulf of Mexico. That rainfall is from that tropical disturbance or potential tropical disturbance. High pressure keeps it out of the way through the end of the week, but it's still going to be problematic as we get into our weekend, because at that time a really powerful low will be sitting here over basically the Hudson Bay, but it'll drape a front all the way down to the south. Now it's not going to do too much because the big high pressure is going to be in place, but watch what happens once we get into Sunday morning, Sunday afternoon, and Sunday evening. Now at that point, this low pressure system you see here as forecast by the GFS is actually the remnants of a typhoon that hit Japan on Saturday, a few days ago. And that particular feature is going to help draw up the leftover moisture from this tropical disturbance and potentially bring in more heavy rainfall into this corridor. Now, there is a difference in our model runs. This is 7 a.m. Monday. The low pressure center, according to the GFS, is here. The European model wants it farther north. And why that's significant is that may be able to draw more of this moisture up earlier, giving us another heavy rainfall event. But both models like to do this Monday night, getting into Tuesday morning, Tuesday midday, and Tuesday evening. See that? They bring a big front through about a week from now. Now this is pretty far out in the forecast, which means we're going to have to watch it carefully. But it does mean that over the next 10 days, the potential for bringing in some pretty heavy rainfall here is substantial. And we need to talk about how things evolve after that. And to do that, I just want to show you the figure that's over here on the left first and explain it to you in the animation on the right. We see that in the week 2 forecast time period, that much of the action is going to be centered here in the eastern part of our southern region, while Texas, Oklahoma, that part of it tends to be drying out quite a bit. And the reason for that is best seen when watching this animation over here on the right. Now you're going to see things all play together just like we discussed. Here comes the first trough sweeping through. This is the one that's coming through Tuesday into Wednesday, cooling things down, but on the southern edge the front lingers, and that's where our heavy rainfall comes in the next 48 hours. Now look at the ridge that builds in behind it. See it right here? That big ridge is what brings back up the warmer temperatures and also dries things out a little bit. But the blue you see right in through here, that is the kind of the mid-level and upper-level effects of the tropical feature we're watching. But you've probably noticed the big blob of blue, that would be a deep trough that's coming into the west coast United States. And really its biggest push isn't the first one, which takes us through the weekend, but this one right here, Sunday into Monday. Now right now the GFS ensemble brings that trough into this area, which produces a low right here between the trough and the downstream ridge. And we will get across the southern region the tailing edge of that front. And that system barrels through by Tuesday, Wednesday of next week. And then what is unique about this pattern compared to what we've seen throughout the rest of this year is that by the time we get toward the end of the month, it wants to set up a deeper low pressure system sitting here over the Ohio River Valley. Now if that happens, that's going to keep the eastern half of our southern region and the east coast wet. But where we have this ridge-like feature here going into this trough, on a broad scale we get upper level convergence in this area. That's the opposite of divergence. The divergent quadrant is over here. So that is why you see wetter conditions in this area, and I'll put D for dry in that area. All upper level dynamics. This also warms up the west coast of the United States. And why this is significant is look at what our temperatures do. First trough sweeps through, keeping things in the eastern half of our southern region on the cooler side. But remember that ridge that comes in, that warms back up parts of Texas, Oklahoma, New Mexico. By the time we get to the 6 to 10 day time period, our new trough is digging in and we see a resurgence back toward normal temperatures again across much of our southern region, especially the southeast. But you saw the deeper trough sweep through, and that shows you that by the time we get out to that 11 to 15 day time period, we go back over to the colder temperatures again because the flow pattern is doing this. So putting that all together, that is how we basically build precipitation systems and temperature change. It's amazing to see it all work together. I'm going to finish with one last figure. We got some new data in last night from the European model that takes us all the way up to through the first week of November in this case. And it does appear that during that time we do get some drier conditions moving through part of our southern region here. We're going to have to keep a closer eye on this particular forecast because while I do see things drying out here maybe at the end of October and beginning of November for the southern region, we are going to watch this same area that I'm circling here to get quite active again mid-November. Okay, we'll talk about it on a long-range update tomorrow. Hope you all have a great week, and we'll talk to you again soon. Thank you.